You don't need a formula to find the vertex of a parabola. Unfortunately, your book seems to imply that you do, so forget that. There's a very easy way to figure things like this out. Here's a familiar curve. I'm sure you know what its equation is. Happens to be a parabola. The equation is y equals x squared. Now, notice a couple of features about that curve. It's symmetric about the y-axis. In other words, if you chop it in half, the left half is a reflection of the right half in the y-axis. And the implication of that is you have an even function. Even comes from the idea that y equals x squared or x fourth or x sixth. They all look similar. They all have that same kind of symmetry. And if you put in a negative value of x, like -2, you get +4 for y. If you put the corresponding positive value, +2, you again get 4 for y. So the y-axis, we could call it an axis of symmetry, cuts the curve in a symmetric way. Now, for this lesson, we're going to consider things like where is the vertex and what happens if you do some changes to the graph. In this case, the vertex is the bottom of the graph, 0, 0. The vertex of a parabola is its bottommost point or its topmost point if it's upside down. Now, what if I change it by adding 5 to the function? In other words, y equals x squared plus 5. What does that graph look like? Well, it moves it up 5. So the vertex still has the same x-coordinate. The axis of symmetry hasn't changed. But the y-coordinate is up 5. So the vertex is 0, 5. Let's go back to the original. If instead of adding something to the function, I add a number to x itself, say I do this. Suppose I do parentheses x plus 5 squared. Then what happens to the graph? Do you remember? Does it move it to the right 5? No, it moves it left 5. So adding something to x moves the graph left. Subtracting a number from x would move it right. In this case, the vertex is -5, 0. And the axis of symmetry there is at -5, at x equals -5. Well, enough of that review. Let's move ahead to equations in general. We have a quadratic equation. Here's a problem. Find the coordinates of the vertex, y equals x squared minus 5x plus 8. You don't need a formula to figure this out if you understand certain basic principles. Here's what its graph looks like. You could sort of guess the vertex from this graph, but we're not going to do that. We're going to get it exactly. The concept is, what if I take away that 8? It's the same as saying I subtracted 8 from the function. If I subtract 8 from the function, it's going to move it down 8 units. And the vertex is now down somewhere at the bottom. Notice that you can factor it. You can always factor it if I take away that constant number. In this case, y is x times x minus 5. What are the x-intercepts? Well, the x-intercepts are where y is equal to 0. And that happens at those 2 points when x is 0 or when x is 5. Do you understand? We have the product of two numbers, and we want it to be 0, so one of those has to be 0. Either x is 0 or x is 5. And the important point here is that the vertex, or the axis of symmetry, the x-coordinate of the vertex, is halfway between those two numbers. So what's halfway between 0 and 5? 2.5, right? So 2.5 is the x-coordinate of the vertex. Of course, that one's moved down, but we can move it back up again, and the x-coordinate of the vertex doesn't change. So the vertex has x equals 2.5, and the y-coordinate can be found by plugging that number into the equation. In other words, the vertex here is 2.5, 1.75. Does that make sense? So we could ignore the 8, remove the 8, factor the expression, find the x-intercepts, and then the vertex, the x-coordinate of the vertex, is halfway between those two. Here's another problem. Find the coordinates of the vertex of y equals negative 2x squared minus 9x plus 5. Now this one starts with a negative x squared, so it's an upside down parabola. Let's see what it looks like. Looks something like this. This time I didn't put any coordinates on the axes, so we have to concentrate on finding the vertex. Well, what do? We want to take away that 5, the constant term. That'll move the graph down. And then we can factor it. So that can be factored as y equals negative x times 2x plus 9. And where is that equal to 0? Well, obviously, if x is 0, it's 0. The other place where it's 0 would be where 2x plus 9 is 0. Let's see, that would be 2x is negative 9, so x is negative 9 halves. Do you understand that? So now I know the x-intercepts because I moved it down, and the vertex is halfway between, or the x-coordinate of the vertex, there's the axis of symmetry. The x halfway between those two numbers is half of negative 9 halves, which is negative 9 fourths. So we'll move the graph back up. The axis of symmetry still stays there. The x-coordinate of the vertex is negative 9 fourths. And we can plug that into the equation to find the y-coordinate of the vertex. I decided to change it to decimal numbers, easier to work with, and so if you plug that negative 2.25 in for x in that equation, you should end up with 15.125 for the y value. So there's the vertex. Simple idea? Let's go to the Sally sells seashells problem. You might remember that. We had, when she charged certain prices, she got a certain number of sales per day, and from that we could figure out the profit. It turned out we were assuming that the number of sales per day is linearly related to the price in cents. Negative 3x plus 223 is how many she sells, and you multiply that by the price of this seashell, and that gives you the profit. That 0.01 is given there because the price she was charging was given in cents, and we want the profit in dollars. So in that assignment, we had this equation for the profit, and again, we have a parabola. Now this time we don't have to move it up or down because we can easily find the x-intercepts of this. One of them, of course, is 0. If x is 0, you get 0. If negative 3x plus 223 is 0, then that gives us the other x-intercept. So y is 0 when x is 0, or when negative 3x plus 223 is 0. And that would give us x is 223 divided by 3 if you solve that equation. And the vertex is halfway between those two numbers. The axis of symmetry, the x-coordinate of the vertex, I should say, the axis of symmetry is halfway between those two places. And dividing 223 over 3 by 2, or in other words, half of that, is 223 over 6. It's a little bit easier to use decimals because we do have to find the y-coordinate of the vertex as well. Let's see, what do? When x is 37.167, to find the y-coordinate of the vertex, use that equation up there. Y is 0.01x times negative 3x plus 223. Put that 37.167 in place of x and work it out. Use a calculator. Turns out that y is 41.44, rounded off a little bit. Of course, we should probably round off to 37.167 as well. Just call it 37 because, after all, it's talking about cents. She's not going to charge a fraction of a cent. Remember that? See, so that's another case where it's very easy to find the vertex. Problem 3. Find the coordinates of the vertex here. Y is a factored expression, x minus 2, x minus 6. Now, we don't have to do anything fancy here because we know what the x-intercepts are, right? All we have to do is set that equal to 0. When is that expression 0? It's 0 when x is 2 or when x is 6. Does that make sense? So the x-coordinate of the vertex is halfway between 2 and 6. How do you find a number halfway between two numbers? Well, one way to do it is add them up and divide by 2. In other words, the number halfway between is the average. Well, this one's pretty obvious. What do we have? What's halfway between 2 and 6? It's 4, of course. So the x-coordinate of the vertex is 4. We don't have to do any moving or anything. And all we have to do is plug that in to find the y-coordinate of the vertex. When x is 4, y is 4 minus 2, 4 minus 6, which is negative 4. So the vertex is at 4, negative 4. See, that's how you find the vertex. If you know the two x-intercepts, if it has x-intercepts. If it doesn't have x-intercepts, move it down so it does, or up so that it does. In this case, we know what the x-intercepts are so that we can find the x-coordinate of the vertex and then plug that in to find the y-coordinate of the vertex. That's how it works. You clear? Here's where the book's formula comes from. The parabola in general form is y equals ax squared plus bx plus c. If we subtract c, it moves down, and we can factor it as x times ax plus b. So the x-intercepts are 0 and negative b over a. The axis of symmetry, or the x-coordinate of the vertex, is halfway between those, which gives you the negative b over 2a. But you don't need that formula if you understand what's going on.